Hello, so let us look at number 21 through 25. So 40 slips are placed into a hat, each bearing a number 1 through 10. So that means there are 4 of each kind here. Now 4 slips are drawn from the hat at random without replacement. Let P be the probability here that all 4 uh, bear the same number. Alright, so what's the probability of that happening? Then that means first one can be anything we want it to be. So it's going to be any 40 out of 40 would have been okay. But the second one and on has the same number as the first one. So now since we picked the one out of 4 numbers, so we now have only 3 left out of 39. And next one, since we used the 2 of them already, then we have 2 left out of 38. And last one is 1 out of 37. Now, but how about Q? Q here it says with the probability that 2 of the slips bear number A and the other 2 bears number B, but that's not equal to A. That means Q, first one can be anything we want it to be then. Let us say it's A. Then that can be 40 over 40. Any number is possible. Second number can be also A, for example, which is 3 out of 39. Now third number has to be different from this one, so we end up getting, let's say that's B, then that means we have any other numbers as long as it's not A, then it's okay. So we have 4 of A's, so therefore we have 36 left out of 38 would be another number. And then the last number has to match B, so we end up getting only 3 out of 37. But the thing is, the number that's same as the first number, this can come out on the second slot or third slot or the last slot. So in fact, we have 3 possibilities of getting the second number of the first one. So that's why we can multiply that by 3. Then now what we have to do is we just have to do Q divided by P. Then Q in this case would have been this one. So if I have to just rewrite it, then 40 out of 40 is just same thing, so I'm just going to cancel it out. So we have 3 out of 39 times 36 out of 38 times 3 out of 37 times 3 over P, the first one, 40 out of 40 cancels out. So we have 3 out of 39, 2 out of 38, and 1 out of 37. So obviously we can cancel things out here. These two cancels out, and 38 cancels out, 37 cancels out, and 2 can cancel out with 36, which giving us 18. So 18 times 9 can become our answer. So what is 18 times 9? That's 162. So we have 162 becomes our answer. Number 22. For how many positive number n less than or equal to 24 that n factorial is evenly, so n factorial has to be evenly divisible by 1. How do you add 1 through n? In fact, that's the first number plus the last number times how many numbers we have, which is n, divide whole thing by 2. The fact that I'm dividing it by 2, that's the same thing as multiplying by 2 here. Then one thing which we can do is we can cancel out n from both parties here. Then this becomes m minus 1 factorial times 2. So this simplifies as 2 times m minus 1 factorial divided by m plus 1. You see, m plus 1 is definitely bigger than m minus 1. Only way where n plus 1 cannot be cancelled with any one of these numbers is, yes, if m plus 1 is a prime number. I mean, if you have to be, if you have to be 2, for example, then it would have cancelled with 2, so maybe we should say odd prime number. Because if it's not a prime number, then there must be a factor between m minus 1 all the way down through 1. There must be a number that divides m plus 1 that basically means there must be another number that can cancel it out. So only way that n plus 1 cannot be cancelled with any one of these numbers has to be odd prime number. Now then, from up to 24, or in fact n plus 1, that means up to 25, how many prime numbers do we have that are odd? So it'll be 3, 5, 7, 11, 13, 17, 19, and 23. So total we have 1, 2, 3, 4, 5, 6, 7, 8. 8 of them. So that means out of 24 that's possible. So when you subtract 8, we end up getting 16, which is choice C becomes our answer. Number 23. In a trapezoid ABCD, okay, so let's look at a trapezoid. So here we have, but the area of this one is twice as this one, so I'm going to put A over here, B over here, C over here, and D over here. And we realize that E is the midpoint of BC, and F is the midpoint of DA. So once you connect them, we get to realize that this is the area, twice the area of this one. And I'm looking for the line segment AB over DC. So what if I were to assume that this is A, this one is B, and then this one is C? We realize that since B is the connection of the midpoint, we know that B is equal to A plus C over 2. Now, another thing which we get to realize is talking about the area. The bottom area then is equal to what? Let me just write it this way. A plus B, base 1 plus base 2 times height. Height would have been this way. And in fact, that would be the same height as you can see over here, because E and F must be the midpoint. So divide by 2 would have been the area of the bottom one. But the area of the top one would have been B plus C times H over 2. But this is a twice of the area of this one, so we're going to multiply that by 2. Then here it goes. Bottom 2 cancels out, H cancels out. So here we get A plus B must be equal to 2B plus 2C. Since we can cancel out B's here, then we get A equals B plus 2C. But what is B? B is equal to this one, A plus C over 2. So we can rewrite this one as A is equal to A plus C over 2 plus 2C. When you multiply everything by 2, then we get 2A must be equal to A plus C plus 4C. Then we get A is equal to 5C. But since what we are looking for is AB over DC, AB over DC, meaning what we are looking for is A over C, so we can divide whole thing by C. Then A over C must be equal to 5. So 5 becomes our answer, which is choice C. Number 24. If x and y be two-digit integers, such that y is obtained by reversing the digits. As soon as we're talking about digits, then we can say x must be equal to 10a plus b, where a is the 10th digit number and then b is the unit digit number. But y is equal to 10b plus a, because we switch the digits. Now, integer x, y satisfies this condition. So that means soon as you see this one, what we can do is we can rewrite this one as x plus y times x minus y is equal to m squared. Here, x plus y simply means adding these things together. So we get 11a plus 11b, and then this one becomes 9a minus 9b is equal to m squared. Now, then obviously we can factor out the other numbers here. 9 times 11 times a plus b times a minus b is equal to m squared. So the fact that this one can be a perfect square, 9 is already a perfect square, so that's fine. We have 11. but we don't have 11 is not a perfect square. So that means we are looking for something here that will make that into 11, or product to be 11. So we get a plus b. I mean, 11 is only 11 and 1, so a plus b must be 11, and a minus b must be equal to 1. That's how we can multiply them to be equal to 11. Then this one is perfect square, where this one is also perfect square. Therefore, a product of the squares must be square of another integer. Now, then here, when we add them up, we get 2a is equal to 12, where a is equal to 6. Some of you guys might have guessed it, but that's perfectly fine. Therefore, b must be equal to 5. So that means x must be equal to 65, and then the y must be equal to 56. Now, then if that were to happen, what is m? So m squared would have been equal to 9 times 11 squared. In other words, 3 squared times 11 squared. In other words, 33 squared. So m must be equal to 33. So now, let's try to add them up and see what we end up getting. So when you add them up, these two, we end up getting, this becomes 1. And then, so this ends up in 121. But add up to 33 becomes 154. So 154 becomes our answer, choice C. Number 25. Let's look at this one. Subset B of a set integer from 1 through 100 inclusive has a property that no two elements of the B sum to 125. How can you have sum to be to 125? That's possible if we have, I mean, maximum is 100, so minimum has to be what, 25. And 26, and it becomes 99. 27, then it becomes 98, and so forth and so on. Now, but the closest one will be 64, and then, no, not 64, but 62, and 63. Because if I have any one of these numbers and any one of these numbers, and if I have pair of these numbers, then obviously sum to be equal to 125. So I can either take any one of these numbers, or I can take any one of these numbers, or one of each pair. So one way or the other, let's think about it. So that's what the condition that which we have. But if you have 1 through 24, no matter what you pick, this will never be add up to 125, since we are only adding two numbers with the maximum of 100. So that means the easy way for us to do is 1 through 24 and 25 just carry all the way to 62. So those are the numbers. Those are the maximum number of elements that which we can have in set B. Either if we have any one of these, then that will have a match to add up to 125. So our answer will be 62. Choice C. All right. I'll see you later.